Okay, we should be on.
Hello, everybody.
It takes the highest with the bounds.
Hi, everybody. You know me. My name's Tom. So hopefully by now everybody remembers my name. A couple of things. First of all, if you need Sea Lion license, drop me an email. In the subject, put Sea Lion, and inside the email, put your name, your surname, and email address. Then I can just copy and paste and send you back the license. Yes. If you want any latest updates about our classes and so on, follow me on Twitter, follow our website, and obviously you will be updated. Next, our next two classes, so basically next 2 weeks, are not happening here because they are very busy. They got commercial bookings. We have 3 class, so we got a booth. But we have a not far from here. Do you know Mimecast? Remember Mimecast? Yeah. Yes, just up the road. 2 minutes. I'm just hoping Oli will confirm. I mean, he said yes, so I suspect we are 100% there. So book on our website because Mimecast does not have the booking system, and for the insurance purposes, security and so on, they will not let anyone into the building if I don't have their name. Because I have to pass the names to the security. They have to print the badges, and if they don't have that, well, you will be refused. Even if there's space, they will refuse you to get inside. So for your own good, make sure you are registered. Next thing is some requests for your creative stuff. We want some help from you. We have a blog session, as you fully aware. If you would like to write, raise your profile, write a blog post about us. Yes, write blog. What made you motivate to start learning C++? Why are you doing it? As well, you're very welcome to write blogs for different websites like dev.to or Medium or something, and write about us. Let the other people know, because we still find so many people doesn't realize we are here every week, and obviously we're making hopefully a positive change in your lives. So let the other people know. Shortly we will send you a survey, hopefully this week, and we'll ask you some of the questions. These questions are basically to help you to communicate what we're doing right, what we're not, are you happy, what we should change, what topics we should cover, and so on. And that kind of stuff obviously helps us. So reply to that. Please do fill them in, because that will really help us. Without this knowledge, we assume we are perfect. I know we are, but what else? Sea Lion license, I told you. Oh, do you know something called CPP cast, a podcast? Anybody? No?
Well, if you're a C++ programmer, it's
okay.
the most well-known podcast.
Yes,
probably the only one.
You know the podcast.
That's one of 2.
The thing, yes. So it's like a recording of audio about C++ news and so on. You're very welcome to start listening to it. It will help you to get adjusted to things C++. It's a very good podcast. And the good news is, this week we will be about us, C++ London. So you can listen about us.
So tune in, or whatever you do to podcasts.
They are pretty much the only one podcast. I mean, there is an extra one called CPP Chat, but they just restarted. So for now, you can pretty much say there is only one, you could say. If you'd like to contribute in any way, yes, even, as I said to Alex, you're a bunch of clever guys and girls. We have once a week, usually Thursday or Friday, a lunch. if you think we can do something better, or just share your ideas with us, you know, oh, maybe we could try this or try that or cover this material and so on. Come for lunch, yes. We got a working lunch, so basically we go, we eat some lunch, and then we go and we discuss what we're doing for the next coming weeks to cover for the classes. You're very welcome to come. We you know, without your feedback, without your input, as I say, for us it's difficult. So if you think you can do something, you can basically help us in another way, just join. You know, you pay only for your long lunch, whatever you eat, and then we sit down and have a chat for a couple of minutes, half an hour, and then off you go to your work. Just yeah.
That is CPP.
And finally, just to remind, we got a gold rule that our teachers should be looked after. That means, yes, if we're going to the pub, because one or two people doing this on a regular basis, when these guys are doing this for free, so we need to make sure that they are fed and got 1 or 2 pints at the end. So please join us in the pub and pay gratitude to the teachers. That's all from me. Thank you very much. And I'm stop talking rubbish, and I'm passing to Christian.
All right. Good evening, everybody. I see some new faces. Who's here for the first time tonight? Excellent. Okay, well, you've joined in at session 5, as you may have been able to tell. So we're sort of jumping in, not quite at the deep end, but we've paddled out a little way from the shallow end. So if you want to have a look at what we covered in the first 4 weeks, we've got a GitHub repository that's got all our slides on, and also we've got a YouTube account that's got all the videos, so you can listen to me waffling for a couple of hours. And that'll help you catch up. So if today it seems a bit sort of, whoa, this is a bit scary, it's not really. You can catch up. We're not too far ahead. You're not in week 25. So if you do have any questions, if you have any problems setting up when we come to the exercises and stuff, just stick your hand up and I can help you, or Jacob can help you, or Ollie when he gets here. Yes, on a personal note, by the way, I've been in a British Standards Institute meeting, C++ panel all day. My brain is completely frazzled, so if I'm not quite as on the ball as I normally would be, I apologise in advance. I'm on my last legs. But never mind, it's 2 hours, I'll get through it. We'll be fine, we'll be good. I'll get a coffee. Right, feedback. So for the new people, we have, I don't know if you've heard of Slack. It's like it's basically IRC for the web. But there's a CPP Lang Slack channel for discussing C++. A couple of thousand people on there now, I think. But we have our own room in there. To join it, go to this URL, enter your email address. They'll send you an invitation to join. It's not a very exclusive club. So if you go there, you can chat to us. You can chat to other students. You can discuss things. Please do join us. Second thing, again, for the people who are joining us, this is the textbook we're using for the class. It's a fairly weighty thing. You can get yourself a physical copy, or the ebooks available. But certainly most of the homework exercises are coming from the book. And as we go on, we're going to start doing more and more from the book in the class as well. Any other announcements? Oh yeah, you're not going to see me for 2 weeks. I'm on holiday for the next couple of weeks. So you're going to be taught by Ollie, I expect. So yeah, it was only going to be the week after, but it turns out my flights mean I can't do next week either. I'll be watching on YouTube next week.
Okay.
Sending snarky comments on the, yeah.
Where are you going to?
Where am I going? I'm going to Greece. Hopefully, yeah.
Hopefully.
A week in the sun. Yep. So that's all the announcements. Shall we get on with doing some C++? So last week was a week ago. It's quite a long time ago. It feels like a long time ago for me. We covered an awful lot, really, didn't we? Value semantics, passing by value, talked about scope, basic object lifetimes, automatic variables, saw how their lifetime is governed by their scope. So when a variable goes out of scope, its lifetime ends, it gets destroyed. Very important central concept. Just take this opportunity to mention it just one more time. And we also looked at some basic control flow statements, ifs and loops. Actually, now I come to think of it, none of which you'll be using in today's exercises, so I could have planned that a bit better, but never mind. This week we've got a little less on our menu, but still important things. So reference semantics. We talked about value semantics last week. This week, reference semantics. We're going to talk about references and const references, what the difference is, and then we're going to talk about pointers, which is scary, right? Pointers, terrifying. No, they're not. They're not. Pointers are easy, mostly. Unfortunately, kind of easy to make mistakes as well, but that's why we've got references. But you still need to know about pointers because they do come up, so that's what the second half of today is going to be about. Does that sound all right? Excellent. So, a revision, because like I said last week was a long time ago. C++ uses value semantics. So, all but 4 or 5 of you were here last week. What do I mean by that?
Values are passed when you pass a value from a variable to another variable. Perhaps it's better to say it as another position in memory. The value is copied. It's not a reference to.
Yeah, absolutely. It means roughly that copies are distinct. So if you create a copy of a variable and then you modify the copy, the original doesn't change. But another way, if you make a copy and you change the original, the copy doesn't change. So last week, I was waffling about t-shirts and magic clothing machines, and Ollie came up with a much better analogy for this. So he was talking about a Word document on your computer. Right? You've got your document open in a window, you can edit it, you can change it. What you can do is you can open another separate Word document and copy and paste the text that you had in one into the other. Yeah? And then when you change the first document, it doesn't change the second one. They're independent. They're 2 different files on your file system. And that's what we mean, well, roughly what we mean by value semantics. They're independent variables in memory. That analogy might come back later. So a little example of what we mean by value semantics. So declare a variable A of type int, we set it equal to 1. And then we create another variable B, whose value is initialized as a copy of A. So what's the value of B here? 1. Excellent. So now we change the value of A. We assign the value 42 to A. So A has value 42. What is the value of B? 1. Superb. And then we can go through and we can have a look at the same thing for strings, just to show you that they're value types as well. We've got S and S2 because I suck at naming things. Now we say S plus equals S2. For strings, plus means concatenate, plus equals means concatenate and assign. So this adds S2 to the end of S1, S as I've called it, because I suck at naming things. So what's the value of S now after this line? Hello world. Excellent. And what's the value of S2? World. Perfect. You've all got this. Excellent. I did a good job last week. No. We didn't have time with Ollie. We were both busy. Something to do next week. Okay. So let's talk about reference semantics. First of all, I spent last week telling you how great value semantics were, and they are great. And the reason they're great is because they allow us to reason locally about our functions. And what that means is if a function takes its argument by value, it's going to receive a copy of whatever you give it. So whatever it does to that function, whatever it does to that variable, it's not going to affect the thing you gave it.
Sorry, can I say again?
Yeah. Okay, so if you have a function that takes an int, say, by value, then when you pass a variable into that function, the function receives a copy of the int that you gave it. This is what? I don't think I'm your name, sorry. Yeah. Alex. That's what Alex was saying, roughly. So passing by value means that the function receives a copy of the variable that you give it. Okay, so we had that example. We had an example last week showing exactly this. So by reasoning locally, it means we can look purely at that function and know exactly what's going on because we've got a copy. We know that the value of our variables isn't magically going to change because some other part of our code, perhaps in another thread or whatever, is going to mess about with it. Because that argument is local to our function. And from the calling side, it means that that function is not going to mess about with our local variables. It's probably a pure function. So we put something in, we get something out. And then if we want to do an assignment from that return value or whatever we want to do, it's all going to be local in our function. So this reasoning locally is a big deal. Functional languages are very big on this. Not that C++ is a very functional language, but unfortunately there's a problem. Can anybody think what one of the, not a problem, but one of the downsides of passing by value everywhere would be?
A lot of copies,
a lot of copies, a lot of memory. Absolutely, yeah. So if you've got a vector that's got a billion things in, you don't want to be copying that all over the place. Because first of all, it's going to be very slow, and secondly, it's going to chew up all the RAM in your system. And this is one of the reasons, there are a few reasons, but this is one of the reasons that C++ allows us to opt in to using references instead. So another reason is when we come to do object-oriented programming, inheritance and things, you need to use references there as well. That's actually why they first got added to the language, but avoiding copying was a nice benefit as well. I told you I'm a bit frazzled, sorry. So, how do we declare a reference in C++? One little character, an ampersand, an and symbol. So, this is not a reference, this is just a normal value. This is a variable I of type int. And now I've declared another variable called ref. And this has type reference to int. This little and symbol here, when it comes after the type, means reference. This is a reference to an int. So we're going to do quite a lot more about this. If I was teaching next week, I'd make you do an exercise, a really nasty exercise on reading types, because they can get quite complicated. But the simple gist of it is we read them from right to left. So this is a reference to an int. We'll sometimes lazily call it an int reference or an int ref. If you want to be formal, reference to int. We always need to initialize a reference. So if we left this bit off, if we just put a semicolon there, the compiler would tell us, you can't do that. That's an error. You've got a reference that you haven't initialized with anything. Reference that doesn't refer to anything. That's not allowed. So that's how you write it, but what does it mean? What is a reference? Well, the easiest way of thinking about it is that a reference is a new name for an existing variable.
So once assigned, you cannot reassign to another variable?
Correct.
So
Absolutely, yes. Yeah, so that's quite an important property of references. But I'll talk a bit more about that in a sec. So we can think of it as a new name for an existing variable. So if we go back to thinking about our Word documents on our computer, a reference is like opening a new window, maybe on the next screen, that has the same document open. So now, if you start editing the document on the left, your changes are magically going to appear on the right because you've got the same document open in two windows. If you use Google Docs, you've probably seen, shared somebody else editing it. You're getting a view of the same bit of memory. So it's a new name for an existing variable. So anything we do to the reference changes the original variable. So it's the complete opposite of the value semantics I was just talking about. And this anything we do to the reference includes assigning to it. So as Giacomo was saying, once you've created a reference, you cannot make it refer to a different object. So let's have a look at a little example of this syntax. So we're declaring it a normal int I. And now, just as I did a second ago, ref is a reference to an int, a reference to I. So now we can assign through this reference. So we say ref, this variable, this int, reference to int, called ref, we set it equal to 42. And what this has done is this has set I equal to 42. Because ref and I refer to the same thing. So by assigning through the reference, we've changed the value of I. That make sense? Yeah. Okay, so now we go to work on I again. So I is equal to 24. Well, now what do you think happens if we print ref? We say, see out ref, new line.
24.
This prints 24. So who said 42? I can see why you think that, because I was just talking about value semantics. And now I've leapt on to talking about the complete opposite. So it was a bit confusing. But the point is, ref and I, these two names, refer to the same variable, the same bit of memory. It's like having, yes?
Can you make a reference to another reference? So could you make another, say, ref2, which is int and ref2 equals ref? Will that still point to the same memory address?
Yes.
Okay.
Yes. So when we say ref equals 42, this is exactly the same, and will generate exactly the same code when you compile it as if you had said I equals 42. Because they're two different names for the same variable.
Are you going to talk about scope later?
Yes?
Cool.
Well, no, actually, no. Come to think of it, sorry, no. What's bothering you about scope?
So if I exist within a function,
Yes.
and that function finishes,
Yes.
but ref still exists, ref is created in another function,
Yeah.
but I guess if neither of them are global, it doesn't matter, right? They have to be in the same function to matter.
What you're worried about is dangling references, right?
Probably, yes.
Yeah. Having a reference to a variable that has gone out of scope.
Right.
Yes, that can happen. The most usual way that it will happen is if you return a reference from from a function, a reference to a local variable. It's something you have to be careful about, but because we always have to initialize references, and because we can't reseat references, we can't change the thing they refer to, it doesn't tend to happen that much, right? Because you can only create a reference in a scope that I already exists. So if you create a reference in the inner scope, the reference is going to go out of scope, and I is still going to be alive. So you can get into a situation where you get dangling references, but it's not all that common. I've got a whole slide on dangling pointers because it's very, very easy to do with pointers. That's one of the reasons we prefer references to pointers. So yes, you've gone way ahead to the end of the session. I think that's pretty much the last slide I've got. So you're 2 hours ahead of me. So you're doing pretty well. So anyway, yes, I was saying. We set ref equals to 40, ref equals 42. This changes the value of I because ref is a reference to I. And now here, when we say I equals 24, this is exactly the same as if we had said ref equals 24. Because I and ref are looking at the same bit of memory. So when we print out ref, we get the last thing that we assigned to that bit of memory, which was 24. And then we have exactly what was asked a minute ago. So now I'm creating a new variable called ref2, which is, again, of type reference to int, and I'm standing right in the way of the screen, sorry. Creating a new variable ref2, its type is reference to int, and I've initialized it with ref. Now I haven't done it, but what if I said at the bottom here, standard cout arrow ref2, what's it going to print? 24, exactly, because it's just another name for this thing up here. We've now got 3 names for the same thing. You're really concerning me there, Jacob, because you're sitting there like you were judging my explanation of references. Ref2 is another reference to I. Oh, yes.
If ref2 was, for example, just a normal variable, like
So
if it had different value.
If I didn't have this little thing here,
Yeah.
yes.
And we were trying to reference it, the first ref to ref2, what would happen? Because like they have like 2 different places in memory. Yeah. One will disappear, one will be free again.
So think about it like your Word documents, right? So when we have this, we've now got 3 windows open on our imaginary desktop, looking at the same document that we're trying to edit. So we change it in any of the 3 windows, and we see the same thing in all 3 places. But now let's just imagine that I left off this little ampersand here. So it just said int, let's call it j instead, or perhaps on another line, int j equals ref. That creates a new variable of type int, not int ref. That's a new, in our imaginary analogy, a new separate Word document. We've initialized it from ref, but we could just as easily have initialized it from I or from ref2, because what that means is copy and paste any of the 3 windows, because they've all got the same thing, copy and paste that into our new, completely separate document. I really like the Word document analogy, by the way. We will come back to it even later on, so you'll go away today thinking your computer memory is Word documents. It's not, it's an analogy, but it works quite well. Sorry, does that answer your question?
Yeah.
What happens if you say ref2 equals ref plus I? Does it just go?
What do you think would happen?
Just go over and over and over.
So they're all at this point equal to 24.
So it would be.
So
48.
if you had said ref2, so you're saying ref2 is a reference,
Yeah.
and it's I plus ref. What do you think is going to happen?
Just go off to infinity.
You think it's going to go mad?
Yeah.
Anyone else think it's going to go mad? I'm hearing no's. That's probably because my tone of voice suggests that it's not going to. Right. I'm giving away the answer.
We'll just update all three to the whatever the ref plus I is. It's just like assigning it.
Okay, so if we down here said ref2 equals ref plus I, what's going to happen?
Oh, sorry, plus I. Sorry, I thought I is like arbitrary integer.
No, I is this one. So what it's first going to do is do ref plus I on the right-hand side. And the compiler is going to work out what that is. It's going to say 24 plus 24. And it's going to create a new temporary integer with that result. And that temporary integer is going to have value 48, because 24 plus 24. And then it's going to assign that temporary to the thing on the left, which is ref2. And so after that's happened, I, ref, and ref2 will all have value 48. So it...
Okay, it's not going to go.
No. So
it's not an infinite loop.
No, so they thought about this because it is quite a common thing to do. It can, as we'll see in a minute, when we pass by reference, it could happen unintentionally. So it's well defined why this happens. It creates a new temporary value so that we don't get this infinite recursion, and then it assigns from the temporary.
One more question.
Oh, yeah.
Is there any performance difference between using the ref of a variable and the variable name itself? Like, does the ref actually have some sort of property that says, okay, I need to go to I, and then from I need to go to
Absolutely none whatsoever.
Okay.
So if you, there's a web, well, if you can read x86 assembly, there's a website called godbolt.org, which is brilliant, and it lets you type in C++, and it shows you like the machine code that the compiler generates. Now, I can't read assembly code, but what I can do is see that if I make changes and it does the same thing on the right-hand side, that means it compiles to the same thing. And what you'll see is if you do this thing with the local references, you will get exactly the same machine code. It makes no difference. Where was I? Pass by reference. Now, having local references in the same scope as we just did, that's a bit pointless. Why would you do that? Why would you create a new name for something that you've already got a handle for? That's not very useful, right? But what is useful is passing by reference. So we saw this last week. We were talking about it a moment ago. C++ uses pass by value by default. So when you call a function, give it the arguments, if that function has a parameter of type int, it will receive a copy of the thing you give it. But we can also pass by reference. And the way we do that, you probably could guess from what I've just told you, if you didn't already know. Instead of declaring the function parameter of type int, we declare it as type int ref. And what this means is that the function will operate directly on the thing you pass to it, not on a copy. It's passing by reference, so completely the opposite of all the examples we saw last week. So we're avoiding this copy into the function by passing a reference to our variable. So this is a function declaration. Function called say hello has return type void. Takes a single parameter of which is named name. What's the type of name? String reference. Reference to string. Yeah, string ref. So now, inside our function, the body of the function. Oh, I told you I wasn't on the ball. name equals hello plus name. Let me just rapid fire edit, right? So just as it always was, name equals hello plus name. So now we're doing exactly what you were asking about a moment ago. We've got this string ref here. Remember, plus for strings does concatenation, glues them together. So we're gluing hello onto the front of the thing. And then we're assigning, and so this creates a temporary string. And then we assign this temporary string to our name variable.
If you return hello plus name and assigned the function call to a new variable,
yeah,
that would be passed by value outside.
Okay, so you'd have to change the return type.
Of course.
Yeah. So if you change the return type to standard string, then we're going to return by value.
Yeah.
Yeah. You can return by reference. It's a perfectly legal thing to do, but it's usually not a good thing to do because, well, it depends on, as everything in C++, there's unfortunately reasons why you do things that are sometimes a bad idea. But in general, if you're returning a reference, it should only be a reference that you were passed in the first place. You can never return a reference to a local variable. Because what happens then, the function goes out of scope, that variable gets destroyed, but you've passed someone else a reference to it. A reference to a variable, and that's, as we were talking about dangling references, that's the easiest way to get dangling references.
You don't get the warning from the compiler?
If in simple cases, yes, you will.
Okay.
Yeah. The more complex cases, it can't always work out exactly what's going on. But yes, simple cases, you certainly will. So now we're outside the function. We just declare a variable of type standard string, so not a reference. This is just a normal string. Initialized as Tristan. And we call say hello me. So we pass me into this function. Now this function takes a reference to a string. This function takes a reference to a string. So rather than taking a copy, now it's going to operate. It's going to operate on me directly, which will be interesting. It's going to operate on me directly. So name up here becomes a new name, a new view, a new window to the same bit of memory as this variable me. So when we do this assignment, it's going to change the value of the thing we pass to it. It's going to operate on a reference to me. So if I now print me, what's it going to print?
Hello, Tristan.
Hello, Tristan. Yes. Because I'm a very sad person, I like to make the computer say hello to me. So is everybody clear what's going on here? Oh, you've got a frown on your face.
No, I'm not sure.
Okay. What's bothering you? I mean about this, not like... We have a group therapy session, but maybe we should concentrate on C++. I know a bit more about that.
I'm a bit lost in the while I was writing, taking notes.
Oh, okay. So I'll just go through the example again. So we've created a string called me, and we've initialized it to Tristan.
Yes.
Okay? So now we're calling this function say hello, and we're passing it me.
Yeah.
Passing it this variable.
Yes.
Now the function signature says that the argument is of type standard string reference. And that little and symbol
Yes.
means that instead of getting a copy, like we did last week,
Yes.
This means that it's operating directly on this variable here. So it's not operating on a copy, it's operating on the original thing.
Okay.
So now when we modify name, that's the same as modifying me.
Makes sense.
Yeah. So now, after that function has come back, after we've returned from the function, so we're down here now.
It's going to give us print hello Tristan.
Yeah.
Thank you. I appreciate that.
So me doesn't really actually, if it doesn't know it's got a reference.
Precisely.
Yeah.
Yeah.
So it's just operated on it. There's no history there. It just gets changed.
Yes.
Yeah. Okay.
I don't know who was first. We'll go over here first.
So when you pass by reference,
Yes.
does the system generate under the hood a variable called, let's say, call it ref, because it's not, but it's actually probably not on ref, but something, a temporary variable.
Under the hood, if you really want to know what's going on, this will almost certainly do it by passing the memory address. So passing a pointer. So the way the compiler will actually do this will be by passing the memory address of the thing, of me. Yes.
However, one does know that because if you only look at say hello, which could happen anywhere in your code, yeah? And you actually say hello could be implemented somewhere in the library that's miles away.
Yes.
So when does the compiler know that when you say hello to me, the compiler knows actually this me is not place that I need. It's actually I need to pass that memory location to that thing.
So because you need to declare functions before you call them, so the compiler always knows the signature of the function before you call it. So it sees this bit. Even if the implementation of the function is in a completely different file, we put the declaration in the header. So this is one of the reasons why in C++ we need to declare functions first. C, you can sort of get away with it, old versions of C anyway. But with C++, we always need to declare functions first, and it's for precisely this reason. So that's a really good question. It's because the compiler needs to know, at the point at which it calls the function, whether to give it a copy or whether to give it a reference, that is, under the hood, the memory address. And it knows that because it knows this signature, so it knows that this is a reference variable. Does that make sense? Yeah. You had a question over here.
So if we change me inside the function say hello, it will return whatever we write inside say hello, right? If we in say hello as an argument, we pass me, the variable. We can pass anything there, right?
We could pass any string we like.
Any string we like.
Any string we like. So we could create a second string down here called standard string u with your name, and then we could say hello you, and it would do the same thing again.
Okay.
Yeah.
And also when we're passing like this, we don't need to worry about all of the stuff you said about initializing it and all of that, because you're just passing it.
What do you mean by initializing?
Well, meaning when you first said, I don't know, a few slides back, that you have to initialize a reference when you create it. But
right.
when you do
yes.
this, you don't have to do that at all.
Well, when we call a function, the parameters are initialized with the arguments that you give to that function. So this reference is always initialized. It's initialized with the argument that you give it. So when this function, I think where the stack frame is created, this reference is initialized with this.
And you can just pass it anything.
Any string you like. Yes.
So along that note, if your me was not initialized for some reason by mistake, so your me is a colon and then it's a null pointer, and then you say hello, say to me, what is going to happen here?
Well, it actually wouldn't be a problem with a string. So standard string is we're getting lots more classes in advance now, or at least a couple more classes in advance. So this is a class type, and it has what's called a default constructor. So if you didn't have this bit, if you just had a semicolon there, it would just be an empty string.
So you just pass as
Yeah.
an empty string.
Yeah. But if it was something that's not a class type, like an int, then that would be a dangerous thing to do. We'd be trying to read from an uninitialized variable. That would be a bad thing to do. So that's why we say always initialize your variables.
RII.
Always initialize your variables because it's not always obvious what's a class type and what's not, right? So in this particular example with a string, because it has a default constructor, it would be okay, but yeah. So is everybody sort of fairly happy with passing by reference? Yeah, excellent. Because guess what? You knew that was coming. People who've been here for 5 weeks now. So to the new people, C-Line is the development environment, the IDE that we've been using for this course. I've forgotten exactly who the new people were, sorry. So we, back a couple of weeks ago, we had a big install fest and got everybody set up with that. So if you'd like, perhaps Jacob can sort of go around and help people get set up with that if you want to. You can have a go at the exercise, or you can just sort of look at the person next to you.
Is there any Wi-Fi here? So I can
There is Wi-Fi. The password is We Love Code. While you're all beaving away with that, I'm going to get some caffeine. Much needed. Okay. Okay, you look front to help. So if anyone gets stuck, this gentleman received his certificate last week. So he will certainly be able to help you. So Tom? Oh yeah, but we're just not sorry. That's not true, by the way.
If anybody needs help, just raise your hand and we'll try to go to you depending on the number of people and give you a hand.
Oh yeah, it's not the
Yeah, I think so. So if we remove that reference, it will not change anything because of this code.
Do you have that? Okay, so on the slides are all on here.
Okay. Yeah.
Now,
I'm very far from coding.
yes.
CPT.
and then, yeah, you go to that full address. a repository in there which will make it very low domain. That's what I decided. So the video is on YouTube.
If you don't put main, it's going to give an error because that is not true.
And username on that, I think it's
You declare
If you search for that, you'll get 26 weeks worth of videos because we have all ones from previous ones, but you'll find the recent ones. Sustenance, sugar, and caffeine.
Dinner, lovely.
Sorry?
Dinner, bit of dinner.
Well, yeah, that time, isn't it? Oh, hi. Can you stay down the pub then?
Yeah, have a little chat. I've got one going. Actually.
Could I just ask you a question? So he asked me a question today that was quite interesting. He said he's doing statistics, sentiment analysis. And I think what he is saying is that he wants to restrict the type of data that comes through. So I guess for him it would be maybe text or something.
Yeah.
So is there a way to do that in C++?
So C++ is what's called a type-safe language. So every variable has a distinct type.
Mm-hmm.
So what you would do is you would normally create a class of whatever kind of data you have.
Mm-hmm.
So, and then your functions would take an argument, a parameter of that type. And if you tried to give a different type to that function, it would be an error. Because you're trying to operate on the wrong type of object.
I see. Because JavaScript is dynamically typed.
Correct, yeah. And I think someone told there are four different types. So you've got numbers, dates, arrays, and objects. That's all you've got in Java. The JavaScript, Java has lots of types. In JavaScript, you've only got the 4 types. And then Python and Ruby are a bit different again because they're dynamically typed, but they're strongly typed. So once you assign something to a variable, it has that type.
Okay.
But yeah,
So are you seeing people go from C++ to JavaScript to JavaScript to C++?
The other way, I think a lot of the guys and girls in the class have come from JavaScript this time around. So Giacomo, who's just stepped out, the Italian chap who was sitting on there, sitting over there, he got a lot of people interested. He's a JavaScript programmer, and from some meetup I think he goes to, he got a lot of people interested in the class.
What about WebAssembly?
WebAssembly, I know absolutely nothing about, I'm afraid.
Oh, okay.
No. These chaps, Mike, do you know anything about WebAssembly?
WebAssembly.
WebAssembly.
There's you compile it through Clang. You can actually use C++ for it.
What? It's like I'm scripting.
No, it's... How to describe it?
Because I missed the last class because I was at a JavaScript front-end engineers class.
All right.
So they talk about WebAssembly. And so it's basically, because Node.js makes it quite fast to render.
Yeah.
But with WebAssembly, everything compiles to C++. So I think that's why and it's moving really quickly. So I think that's why a lot of JavaScript people are moving back to C++, perhaps.
So it's basically AOT compilation. So you can write in one of the supported languages, say C++, like a subset.
So distributed as
and
not LLVM.
you literally build a binary, and then that binary you literally just serve to browsers or whatever that support WebAssembly.
Okay. And
it's obviously very performant because it just runs it directly. There's a strict subset instrument of code, so you can't just do anything to it.
Java applets all over again, isn't it? It's just distributing
actually,
bytecode and having it run in the browser.
It's actually better than that. It's not bytecode. It's not. That's the thing of it. It's not bytecode. It's actual CPU instructions.
But then it must be. You can't run the same thing on your phone that you do on your laptop.
I believe Chrome on Android supports WebAssembly as well. But the thing, that's the point, right? You can't build. If you compile WebAssembly for x86, that's it. It's for x86.
Okay.
So you have a separate
That's
one.
the bit that I.
Yeah.
Well,
There's a way where you don't have to make Is there a way
is there a way to do that? Sort of. Kind of. You can do it with duplicate, or it will actually be which is probably exactly what it sounds like. There really isn't any way to solve yeah, I think 2 hours. It's just not possible to do it.
It would be nice to
So
have
yes,
something you can stand there.
Maybe it's a video as well.
Jason Turner. 3 different videos.
Really, proposal about the diagram. What's the difference? Don't bother. That's not
exactly what you said.
Which is great.
Which is great. Well, I feel bad, so I'm always going either that or you and me are just on the same wavelength. Everyone else is going, what?
Reading the news.
Oh, well, nice and sunny out there.
Yeah,
Chucking down the thunderstorms.
They've got limitations.
Crazy. Saturday and Sunday.
There's no batching. Feed a load of lines to draw and fax them to
As the leaf is going down, see the clouds far away. So the skies are orange. There's lightning in the clouds. Not drop rain in the sky, but just kind of play off what's happening. Yeah. You see the lightning. Wish I could. If you imagine, wish I could have sort of captured.
Is that unusual for this country?
Yeah, very.
Very cool.
Is everybody on the list?
You didn't hear me say, I'm not going to be here next week or the week after. Following the herd down to Greece.
Oh, nice.
On holiday. Club in the 90s.
Okay.
No, there won't be. It's with my girlfriend's family. It won't be. There won't be any club.
Yeah.
Week after that as well, yes. I said that everybody. I said to them,
It's gone into my slides.
Oh yeah, I saw.
This is the first time we built. So I'm praying for
So all the means
You pray for life. You pray, have been answered by God.
my house price will go up by 5 times.
That's really amazing.
I do the rain dance every morning.
Yeah, so you need to check that. Yeah.
Be careful, you might be struck by lightning. You should do this.
Second floor flat.
Oh, yeah.
Yeah,
Should be alright. Should be alright. Look at the number of people.
mentally I do that.
You pray enough, you can do everything.
Exactly, yeah.
Still have 1, 2, 3, 4,
Rain dance.
I'm sure there is.
That's a good idea.
But you do that.
Yeah.
Just solve it.
Well, you had to. It's crazy. You have to.
Literal integer to the 42 and a half values.
You only gave 7.
Yeah. Yeah, it's not. Yeah. It's not stored.
We've got a little hat corner going on.
You don't use the loop, use the log. Oh, yeah.
Shall we have a look at a solution? Yeah?
Anybody who is still doing, raise your hand. Okay, I think done.
Yeah. Right, so we're going to have a bit of fun now where I'm going to try and do some live coding on the screen, which is going to involve some messing about with C-line for a moment. So, I've got 14 new messages there.
So what I did is
which one's the one to merge my displays? Whoa, that's very high res.
Wait. Yeah, it's the same thing.
Oh my goodness!
Right.
They just got a nice sheer slack.
Right. Where were we now? Oh, 14 new messages. I was closing all this other crap in the background now. If you're going to be like that about it, fine, whatever.
It's fine. What time did you get here?
6:28. Tom was getting a bit stressed.
Oh, I see.
It's not my fault the Hammersmith and not very good lines.
When you were here, I texted him that you were not here, so he started swearing.
That'll be on YouTube later for posterity.
Right. Where were we? What did I have to do? So we're going to write this function void increment int ref I. Is this big enough, by the way? This is. Okay, so we've got our function void increment, takes an int ref. Inside that, I've said ++i. You could equally do I++ or I plus equals 1. Any of those will do the same thing. But we have a built-in increment operator, so I use that. And now, fingers crossed, when I run this code, in huge, it prints 1. That's that value there. So now, what was the next thing I asked you to do? Calling, oh, there we are. Call increment on a local variable.
Just on other people on YouTube can see you.
They should be able to see what's on the big screen. Yeah, they're just a couple of minutes behind. It's a bit of latency.
No, it's not. Let's change OBS to that source. It's probably on set to the wrong source.
Okay, that might work better. Sorry, we're...
You've only got one desktop, right? How many desktops have you got?
So, do you know what the difference is between I++ and ++i?
One happens, it's the order they do it.
Yeah.
I'm not 100% clear on what is that order.
++i increments and then returns the value from the increment, whereas I++ returns the value and then increments it.
Almost, yeah. You're basically right. So this is pre-increment. So it does the increment first and then returns you the new value.
Yeah.
And what I++ does is it increments it, but it returns you the value it had before. And in terms of like efficiency for ints, it makes absolutely no difference. If you needed to use the return value, which we don't here, then it might make a difference. But for ints, performance-wise, it's not going to. But for our own types, particularly iterators that we'll get onto much later, it can make a difference. And so generally, it's a better habit to do pre-increment, to do ++ first, because then you don't have to create it. Sometimes have to create a temporary variable. Yeah. Basically, use ++ unless you have a good reason to use pre-increment. We still can't see. Well, this is going to ruin things because this is how I was going to do the solutions.
Check the OBS source.
I don't want to stop streaming, that's all.
No, you shouldn't need to. You can do it live.
Oh yeah, it is not showing.
Just right-click the display capture source. Right-click on the source, display capture. No, display capture.
Oh, down here?
Right, yeah, right. Properties. Bottom of properties. Can you change the display?
No, because I'm now mirroring the display.
Source, then. Add a new source.
Which one do you want? Display capture again.
Can you not set it to do window capture? Set it to window capture and capture the actual window. Just give it the name. Cool. Which one is it? C9? Yes. Okay. And it's on top anyway, so it's fine. That'll do it. I should do it.
Can they see that?
Yes.
Yeah?
Yes, they can.
Okay, so the next thing I asked you to do, try removing the ampersand from the definition of increment. So, does the code still compile? Yes. What happens?
Well, nothing visually. It gets compiled, it gets implemented internally, it gets thrown away.
Yeah. So if I run this, we'll see this time it prints 0. So why does it print 0 this time?
Because incremented value dies inside the scope of the function?
Perfect answer. Yeah, absolutely. So now we're not taking our argument by reference. We're taking by value, which means that this function is receiving a copy. So then we increment the copy, and when the function ends, we throw the copy away. So, very good, all of you. Now something a little trickier. What happens if I do that? Oh, let's change that back to an int ref. What happens if I do this? Well, you've got a red underline, which is a clue that something bad's going to happen.
You get an error because like the in the parameter will say look for an int that is a reference, and 42 is just a value. It doesn't refer to anything.
Yeah, so the helpful message is error expression must be L value, which is perfectly correct, but not very helpful when you're starting out and you haven't come across L values and R values yet. But 42 is a constant, right? We can't increment a constant. That would be silly. So when we call it with 42, it gives us an error. And if we try and run this now, so no matching function called to increment, candidate function not viable. Again, not a very particularly helpful error message in this case. But the point is, it doesn't compile because we're trying, if you really want to know, we're trying to form a non-const reference to an R value. But we're trying to modify a constant, and we can't do that. Oops, that's not right. Tell me if this is messed up on the screen this time, Tom.
It's good. It's good so
far. This worked perfectly when we were trying to do it before.
You might need to adjust the scene. The canvas isn't quite right. Chopped off some of the bottom.
Oh. Anyway, because it's good practice to have, well, to do exercises with references, to get used to dealing with references, to handling references. We've got a second exercise, a bonus exercise. You thought I was going to go on and natter some more. Bad luck, or good luck, I'm not sure. Anyway, we've got a very slightly trickier function to do this time. We want to swap two strings. So now you've not just got to think about references, but you've actually got to think about how to implement a swap. Which is one of those things that is a standard exercise in programming, computer science. Yeah, but okay, without using standard swap or string.swap. Do it yourself, don't be lazy. Switch the scene, I did.
No, but it's still set to C line. Just swap the order.
I did swap the order.
No. Then do another window capture.
Another question.
Yes.
I think I missed something because you passed by value.
That's a copy, yeah.
It's a copy. But earlier we had the 3 Word documents. We were talking about passing by reference.
Yeah, the ampersand, yeah.
Yeah. But those are 2 copies. So I think I'm confused about the copy thing. Because we said we opened 3 Word documents or 2 Word documents.
Oh yeah, so Ollie wasn't here for that bit. So I was using your nice Word document analogy because I really like that last week.
That concept. Okay, yeah.
So when we're dealing with things by value, we're creating copies. So you can imagine it like you've got a Word document open on your computer. It's got text in there. And then when we create a copy, it's like we're creating a completely separate file on the file system, and we're copying and pasting the contents of that into our new document.
Sister.
Sorry.
Thanks.
That's by reference.
No, that's by value.
That is by value.
So that's by value we're copying.
Okay.
So it's like we're creating a completely new document, and we're copy and pasting the text into that.
We take a value. We don't take a reference. If we take a reference, it's referring to.
So, but if we're using this Word document analogy, a reference would be like another window that's got the same document open.
Okay.
So two windows looking at the same file on your computer. So then when you edit it in one window, it magically appears in the other.
Okay, so by value, you can alter the copy, and it's not going to affect the original.
That is exactly right.
Okay.
Perfect.
All right, great. Thank you.
Spending a lot more time going over this reference and value stuff than I did last time, but I think it's actually worth it.
Reference refers to something.
Yeah.
By value is just a copy.
Sorry?
Can you use the Word document R values?
Not off the top of my head.
Yes, I could do something for that. It's in, so that's like the temp folder where Word internally creates a copy of the document. Well, not a copy, but a version of the document.
Yeah,
right?
That's a good one.
So the temp folder will eventually expire. But what it will do is if you have that temp version, when you hit save, all it does is it takes that one from the temp folder and just overwrites what you previously.
So you know when Word crashes and then it says, you relaunch it again, it says, we're trying to recover this document. Something like that. Don't ask difficult questions. This is week 5. Swaggering around with your certificate at the back.
Do they have to be strings?
Purpose of the exercise, yes.
What else would you like to swap?
I'd like them to be integers, or numbers at least.
Oh, that's too easy.
Do a version for numbers if you like. Do you have to change the code a lot if you use numbers instead of strings? The implementation of the function?
Well, the way I'm using the way you do numbers where you just do it using math and you don't actually, I mean technically it's creating a temporary variable, but it isn't like I'm creating it, C++ creating it straight variable.
I could make your code break horribly. Integer overflow.
Now you want to make S2 S1, because S1 is S2. So S2 is 6. So it needs to be something else first.
You're saying on into S1, and then S1 now is 1. Oh, just 2. Saying
But yes, I have seen that done with But unfortunately, there's no minus operator for strings.
There is.
Oh, well, yes, it's not spelled minus, but
it's just much better. Because I have to really think about it. I'm not quite sure.
Yeah. That equals X.
Because then I have to create a number temporary.
No, that's exactly what I'm about.
that real? No. I'm actually trying to load that URL.
Have you turned your laptop into the matrix?
For each Ubuntu.
What is that?
Feed not found.
What is it?
It's free.
No, what is fridge? What you want to?
It's nothing. What do you have a fridge?
Fridge.
And what do you do
Wait, is that
from the fridge?
Is that Ubuntu?
Is there an example using a search?
Like the
Yeah, I
fridge feed.
I meant to do it. I meant to show an example using a search when I was doing the last solution. So, I meant to. Yeah, when I did the last solution, I intended to show you the search, but I forgot. So
search.
I'll show it when I do the solution. Sorry, that was me just. I was getting distracted by the streaming. Are we, Tom? I kicked off the streaming again, but I feel like it might have just created a whole new.
No, it's still live. It's good.
Yeah.
It's all okay.
Okay.
That's right. So I'll just run the test.
Whereas doing JavaScript, it's making function declarations, saying the difference between statements and expressions.
Okay.
I'm looking through there. So I see void. Does it mean void? Void means statement.
Void is a. It goes where you put a type name. Void is a special type. It means no type. It means nothing. So when you have void in front of a function, that means that function returns nothing. So in C++, a function either returns one value or it returns no values. And if it returns no values, you write void. Otherwise, you write the type of the thing you're returning.
Okay, so I guess my question is it important to C++ developers the difference between statements and expressions or expressions?
It is, but you won't find that C++ programmers really kind of fixated about it so much. So we don't have.
Hoisting?
I'm not sure. You mean like returning functions from functions?
So like you have a call stack,
Yes, absolutely.
Okay, so when you have a variable declaration, the declaration gets hoisted to the.
Oh no, absolutely not. So this was something we went over in very great detail last week. The idea of very strictly defined scopes in C++.
Okay.
So it's really, really important. So we spent a very long time going over it.
Is that discussion or I guess in the
It's
video?
discussion. It's in the video. It's in the notes because C++ has very strict scopes for variables because that's all tied in with the lifetimes of variables. So we don't have garbage collectors. So JavaScript garbage collector language. Once you finish with something, eventually it gets destroyed. C++ it gets destroyed as soon as you leave the scope that variable is destroyed. So yeah, the variable, there's no hoisting variables.
And execution context.
You have a stack frame.
Okay. It's interesting.
Yeah.
I'm going to go there. No operator says right hand understand the script.
Oh, I know. You need to hash include string. Yeah, so where it says IO string, then you need to do it in angle brackets.
Same as
So where you
stream looks.
just write with string.
Why did you change it?
Well, we probably use
Okay.
different compilers.
Yeah, so you're using Clang and you're going to be using GCC. No,
Are you using Slang as well?
Yes.
Yeah, but
They're using different compilers internally. So it just so happens that on your computer, doing an include IO stream includes string, and on your one doesn't.
yeah, so we have different C compilers.
Yeah, I don't know.
Is IO stream
Standard
different?
So I guess the best way to do it would be to directly access that part.
I've done it, but I'm not sure I've done it proper way.
Oh wow. Okay. So
I'm
creating
sure
a
there's a
vector.
much better way to do it.
Creating a vector is
This one.
pushing back to swapping over. That works. You can
It works,
yeah,
but I'm
you
sure
can.
that's a not very good way of doing it.
It's not the ideal way to do it.
How would you, because obviously you can't just swap them. It's in your
No,
own
but,
right.
so what you're doing is you're creating this using it to hold that.
Exactly.
You don't need to hold both values. You need to hold one at a time.
Okay.
So you can do it using one temporary variable.
Oh, okay. Oh, and then just swap them around as per. Okay. Right.
So it's like, you've got two things, so you move that one over there.
Yeah. And then you move that one back. Okay. So you just do it, just a standard string and you just swap them over. Okay.
Well, registered to sign. So this was your first session?
I was watching on YouTube
Oh.
of them, but because I had to work late and I couldn't come on time, or like security matter was already fully booked.
Good to see. Obviously not finding all this pretty difficult.
You had some experience with
Okay.
so some of the things
There's lots of JavaScript programs in this class this time.
Did you hear about us from?
Yeah, because I mean C++ is very different in the way it works. Laying back to
like when you start with like something like JavaScript, and you don't think about all those types of variables.
Exactly. Yeah.
And then going back to like fully objective programming is like completely different.
Yeah, very much so.
Can see why
Did you
people that
Did you hear about us? Did you hear
say like strictly type programming languages, you see what the practice strictly type programming languages go on about how good it is. If you're typing, it's like coming from a language that's
Even now, I made like a stupid mistakes and I didn't know why it's not working because I didn't have a standard library.
Constantly just getting compilers, just the tiniest thing. Getting less and less.
It's the most frustrating thing when you have an enormous program and you've got some incomprehensible error, and it turns out that it's one character because you've got an and where you shouldn't have one, or you haven't put one where you should. It can be very frustrating.
I suppose that unit testing is still from
Oh, unit tests, yeah, definitely need to. I said this a couple of weeks ago, but really, I guess the philosophy of C++ programming is the more errors you can catch at compile time, the better.
Yeah.
We work very hard to only try as hard as we can to make sure that the program will only compile as correct. But you can't check everything at compile time as much as we try. So definitely unit testing is still a very necessary step. You're about to say something?
Did you find us via Giacomo's meetup? Oh, did you discover us from Giacomo's meetup?
I discovered you when I was going for a different meetup. and I was passing by when there was a first
here, code.
Yes, yeah.
Ah,
and I
okay.
checked on the website, and like, I was interested.
Okay. Okay. So your JavaScript, he announced it on a JavaScript-based meetup.
Yeah, and then like then I saw that there were some meetups, but when you announced the second edition on the meetup.
Got it. Cool. Excellent. Very good.
So if I'm making a copy of the reference of something, I can make exactly here you don't have 10%, which makes copy. However, without that 10%, literally make these two that's what
You're right. You're absolutely right. It's something I don't want to kind of labour a bit too much because it can get confusing, like you said. So you're absolutely right. String and is a different type. They're related types. One is a reference to the other. They are different types. A reference variable is not the same thing as an object. The other is so yes, you're right there. They're not the same, but when we have a reference, we can have all the operations that we do on the object. They operate through that reference. They are individual types. Float ref. That would have been quite an interesting exercise actually. So
does it become a flow?
Oh, this would have been a long. This is a good question, right? So now that you've reminded me, I'm thinking, well, I should have probably done that as an example or an exercise. So if I have a function that takes a long, I can pass it into a function because long is greater than or equal in size, so it's going to convert that into a long. Perfectly fine. But if I have a function that takes a reference to a long, I can't pass it into a long. Right? Because when I trigger that, it's going to create a temporary int and you can't.
It just won't compile.
It just won't compile.
Okay.
Yeah, so when you have a reference, it has to be a reference to some variable that has some storage inside.
But can you get overflow? It's just
well, we had this thing about dangling references. Dangling references generally don't have to worry about too much because they only have the limited circumstances. Dangling pointers that we talk about, we won't talk about them.
But what I was saying is that we did that swap. Do something in passing in the log.
If you have a long reference, you can't pass an int into it.
Yeah, but within the function, not only you just add or some to the values, you actually do quite a lot. You change the type. You change that. Like you want to change your passing in the long, you put a type cast it into a double.
So if you show me in code what you mean.
So what you do is basically you want to say something like
we've got to get on because it's not
Sorry, can I ask a question?
Yes.
So with the void, since it doesn't return a value, does that mean it will never have any parameters?
No, they're a separate thing. So you can not return anything. You can take as many parameters as you like.
What would be an example of a void that would actually, because I'm looking at this example and there's
yeah, that's not taking any parameters, but it could take parameters. It could take a bunch of ints or strings or whatever it wants.
then wouldn't it be
Well, it won't give anything back, so it'll do something to the parameters that might ask something.
That's going to be fine.
But it won't actually give back anything. So it takes some input and does something with the input, but it just has no output.
So what's going to happen is you
How do
take your
people
logs,
actually,
multiply it by 3.
programmers actually create that sort of scenario?
The result is
Yeah.
double.
Definitely.
I mean, what would a use case be?
Print into the console, you give it a bunch of data, and it just prints that data to the console. It doesn't need to give anything back because there's nothing to give back. It just makes it print out to the screen.
And it's not
They would say if you're moving beyond sending to the console.
So actually just be careful.
Writing to a database, writing to a file. Again, you can write to some database, so you store the data, but you don't have to give anything back.
It's
Store
just
the
how to
data.
sign from a
Store the
floating
data.
point type to an integer type.
Probably you must
Okay, time is pressing on, ladies and gents.
And you do Boolean, true or false.
So
Maybe it's guaranteed not to fail, you don't care.
Okay.
I'm going to have some fun for the folks who are watching online. Unfortunately, we play this fun game again. One of these windows is C-line. There we are. Right, I'm going to get rid of my increment function for a minute, just because it's taking up a lot of space. Oh, for goodness sake. Yep. I'll know not to do this again next week. Don't do demos. They worked all right a couple of weeks ago, so I don't really know what the problem is, but
Resize the.
Okay, it just worked.
It's not chopped off. Yeah, you need to resize it.
how?
Just go to OBS.
Last time.
Right click in the main window. Right click the big thing. Just right click in it. And then it's go to transform.
Transform.
Fit to screen. Right click on scene. Right click on the scene.
Oh, just you can do it. It's quicker.
Yeah. Okay. This is the display capture or the window capture?
Oh, well, get rid of the display capture. Last time I put the display capture, changed it back to display capture, it crashed.
It's not very stable on Mac, apparently. I've never had
Right, we're having technical issues with the streaming. Apparently, shouldn't do it, can't do it.
Okay. No, it's good now. It's good. Yeah. It's fitting the window as well.
Thank you.
How do we swap two strings?
Add them together, that's the process.
Okay. If you're not being a smart ass about it, how do you swap two strings? How do you swap to anything? Standard swap is a good answer, not the right answer for the purposes of this exercise.
You don't want to give the actual answer.
What we're going to do is we're going to create a temporary variable. Called it temp. I've initialized it from S1. So what's the type of auto here? Sorry, what's the type of temp? String, not string reference. So auto, it does type deduction, but it never deduces to a reference. If I wanted an auto reference, I'd have to write that. But in this case, I definitely don't want a reference. And then we say S1 equals S2. So now we've initialize temp with the contents of S1, and now we're overwriting S1 with the contents of S2, and then we say S2 equals temp. So we have these two things here, move that there, that one there, and that one back there. I'm worried this isn't going to all fit on the screen. So now I'm including this new header, C assert. So the initial C means that it comes from the C standard library, and assert is the name of the header, and that gives us this useful function, well, it's macro actually, called assert. And what assert does is it lets us check that some condition is true. And if that condition is not true, it terminates your program there and then with a message telling you what went wrong. So assert is a really useful function for testing things. So what
does assert works when you enable optimization in your compiler?
It works if you enable optimization, but not if you define the macro ndebug, which is what CMake will do when you compile with optimizations. So basically, assertions are there to check that the logic of your code is correct. And as Jacob was saying, when you compile with the optimizations, when you compile in release mode, as it is in CMake, those assertions are removed. They don't appear anywhere in your code. So it's a useful way of checking, debugging your code, making sure it's right, but it won't have any impact on the release performance of your code. So assert, it's the simplest possible function that you can get these amazing libraries for doing testing. Assert is just a very, very simple function, but it's still very useful. That's why I wanted to show you it as a demonstration.
Does this stop my program with throwing in an error, so I can use it inside that try and catch if we want to play with it?
Assert does not throw an exception, no. Assert just terminates your program there and then.
Okay, so try and catch is useless. There is no way.
Try and catch doesn't work with assert, no.
On that note, do you introduce C++ unit tests at some point?
Yes, so we had one of the best and most widely used frameworks for doing this, libraries, is it's called Catch. And we're very lucky that the author of Catch, primary author of Catch, is a guy by the name of Phil Nash, who runs the main C++ London meetup, whose name we stole, and he came in and did a session for us the last time we did the course, and he's a very busy guy, but if we can nail him down to a date, we'll see if we can get him in again to do another session for you guys, because it went very well last time. What's this complaining about? So let's compile in the Rust program, and nothing happens. We got no output, nothing happened. But that's just an example. I'm going to put a deliberate mistake in here. I've now replaced the capital W with a lowercase w, just to show you what will happen with the assertion. Hopefully this time the assertion will fire. And I've got this. It's got assertion failed. S1 equals lowercase world, and S2 is equal to hello. And it tells you exactly where it happened. It tells you the file and the line where it happened. So assert is really, really useful when you just want to check, do a very quick check to see whether something works.
If it was a more sophisticated program, it also brings me the stack where it's generated, or just the last code?
No, but if you run it in a debugger, what you'll see is as soon as the assertion happens, the debugger will catch that, and then it will immediately show you the stack trace. It'll let you step through all your local variables, all the other things you can do in a debugger. Okay. So assert plays very well with debugger. It's designed around that.
Are we going to play with the debugger?
Not today, but definitely in a future session. Yes, yeah. Yes. Right. Oh, that's exciting.
Now you've got two displays.
Right, yay. Let's get back to this, because we are running out of time. We may not get on to talk about point. Oh, hi.
So why did you have to include string as a header?
Okay. So the standard library is broken up into lots of individual components. Yeah, I was trying not to use the word modules. Components. And in a previous week, week 3, I think, we went over the way header files are the sort of glue that links together different CPP files, different source files. So you send your source files to the compiler individually, and to make sure they all operate, make sure they all see the same function definitions and stuff, you put these definitions into what are called header files, text files containing definitions and declarations. And string is one of the headers that comes with the standard library, and it defines the standard string class and all the operations on a standard string. So it just, because C++ doesn't have a built-in string type, has a built-in integer type, but it doesn't have a built-in string type, it's part of the standard library. That's why we have to put std : at the beginning, much to the bane of everybody in here. So in order to get access to that, we have to say include string in angle brackets, and that will get that standard library header.
Why if you run it without the include string, it still runs?
Because you're using a Mac. So yeah, if you were using, so we actually had this earlier, if you were using GCC, so you're using the Clang compiler, if you were using GCC, it wouldn't
Session
work.
5,
You'd have to do the include string.
Session 5, right? This is it,
yeah?
Yeah. Right,
Can I,
yeah, sorry, go ahead. Hopefully it will just work.
Right. We haven't finished with references. We've got the most important type of references to come, const references. So does everyone remember what the const keyword does? Uneditable. Yeah, read only. I think it was week 2, might even have been 1. It's definitely early on. We can declare a variable as const. Technically, what we're doing is declaring it with a const type. And that means that once we've initialized it, we can't change the value of that variable. So going back to our word analogy, once you've initialized the variable, you can't change it. So it's as if you copy and paste something into your document and then hit the menu option that says, make this read-only. So there is an option in Word to make your document read-only. So you initialize it. Once it's initialized, you cannot change it. That's what const means. Pardon, to get it? So we can't change this now. We've initialized it. We cannot change the meaning of life, uni, and everything. That's const values. We can also have const references. And a const reference means we can't change the value of the object via that reference. Okay? So we're going to have a Word document analogy again. A reference is like having a second window looking at the same document. Yeah? So you've got 2 windows open. They're both looking at the same file on your computer. That is, in our analogy, the same bit of memory in your system. But one of them is set to read-only mode. So you can't edit the text in this read-only window. But you can still edit the text in this one, and when you do, your changes are going to be reflected over here. So a const reference doesn't mean this variable can never change. It just means we can't change it using that name. So just to show you the syntax, first of all, this is right at the bottom of the screen, sorry about that. So we declared an int I42, couldn't be bothered to type that again. And now we've declared const int ref, called ref, and we've initialized it to I.
What is it for the other way around? If I declare a reference which is not const, say to life unit and everything.
You will get an error, which you will see on the next slide, that you can't do it the other way around. Sorry?
If it's a const, it makes sense that you can't change the reference.
So remember what I was saying about reading things right to left. So this is a reference to a const int. And in fact, this being C++, there's more than one way to do everything, so you can even write this as int const ref if you wanted to. And some people strongly prefer that for reasons that I won't bother going into now.
That's important. OBS is still a bit buggered.
So this is just what we had on the bottom of that screen. So we created this variable, mutable. Mutable is the opposite of const. Mutable means non-const. Mutable int I. I created a reference to a const int called cref. We've initialized it with I. We haven't changed the we haven't changed I at all. Right? Doing this does nothing to I. This just creates a new way of looking at I. So in particular, we can still modify the value of I. So now if I print cref, what's it going to print? 24, exactly. This is really the key idea, the thing people trip over a bit sometimes, is just because you've got a const reference, or reference to const, it doesn't mean that the value of the thing can't change, it just means that it can't be changed via that name. So if I try and modify it, if I try and say cref plus equals to 1, so plus equals is an assignment, tries to modify it, this is going to be a compile error. I'm going to say this is not allowed, this is illegal. But now this is what Giacomo was asking a moment ago. So now I'm declaring a new variable, ci. Ci is of type const int. What this means is now that we've initialized it, we cannot change the value of ci. So now we try and form a reference of type intref, called mref, and initialize it with ci. So ci has type constant. We are trying to form a reference to a plain mutable here. I'll start at the top. Tell me. I'll say stop when.
Is the reference cref equal equal 24 if we print cref? You don't know 24 and below the code is basically the same. The const in C equal 42. But if we do int reference me ref equals C, the last line.
Okay, so this is now a new separate thing. I should have put like a dividing line in here, right? So we've now declared a new variable, not a reference, an actual variable, a new Word document, but immediately set to read-only mode. like it's locked on your file system, right? And now we've tried to create a reference to a non-const int, a reference to a mutable int. And if you try and do this, try and form a mutable reference to something that was declared const, you think this is confusing, wait till you get to const pointers to const. Try and declare a mutable reference to a const int, you're going to get a compile error.
My question is why we can still change the variable e if we have a const, there is a reference. If our const is the variable itself, we can't create a new reference.
Create a const reference to a const thing.
Okay, so you can add const to something, because you're creating something that has more limited permissions, right? But you can't take const away. Once you've declared something const, you can't remove it again. So in this is the initial declaration, we've declared it const. We can't take that const away, at least not legally.
So you can have a const int and m.
Yes.
Yes, yes. If we tried to form a const reference to this, that would be fine. Yeah.
If we copy this by value, not by reference, it would work. That int without the...
Yeah. If we copied it by value, that's a copy. It's completely independent. That's fine.
Think of it as like the security of the document, the number, right? If you have a mutable one, that's the low security because you can change it. You can always promote the security to read-only with const, but once you've done that, that security level is stuck there. You can't then downgrade it back to being changeable. So what you could do is you could, if you've got the const int, you could take a copy of that secured one, and then you then made a brand new one, so that's then writable. But the original is still there. All you did was copy it, and it's still not writable.
So
in the natural world, if you think of a constant, it's something like a pi.
Yeah.
0.1415, it's never going to change.
Yes.
And then you do the whole thing. But then the question is that this constant like that, why would you ever need a reference? Why don't you just pass that thing around because it's never going to change anyway? So if that document is locked in and never going to change a word, it's already published. Why do you make copies of it and give people read-only copies or whatever thing?
The point is, it's not a copy. That's the whole thing. It's to avoid the overhead of copies. Avoid the overhead. So, just as we said before, this isn't a very realistic example because you generally want. Oh, sorry, did you have a question?
So it's a good practice. Make a const reference rather than the original value. It's a good practice.
Yes, yes, it absolutely is. And you've stepped ahead one slide and think, what am I doing today? This must mean I'm either going too slowly or perhaps just right. Yes, so as I was saying, this is not a particularly realistic example because you wouldn't usually create a reference to some thing that's you've already got a name for, right? You don't usually have a reference to something in the same scope. What we use it for is passing by const reference. So just as we did before with pass by mutable reference, as we're going to call them now, we can pass by const reference. This means that the function will receive a reference to the thing you gave it, so it will be able to see the value of the thing you gave it, but it can't change that value. It can't modify the thing you gave it. Now, I was saying value semantics are great because it lets us sort of reason about our programs locally. And in particular, if you see a function signature and you see that that function takes its arguments by value, you know that your local variables are not going to be changed by that function. Right? You don't have to worry that your pointers are going to be invalidated or whatever happens. You don't have to worry about that. And it's the same thing with const references. If you see a function takes an argument by const ref, it cannot change the value of that function, the value of that argument. So it's the best of both worlds, right? Because we don't have the overhead of copying, but we can still, it's easy to reason about. And also it's just another time to mention, I did mention it several weeks ago now, make variables const if you can. Right? It's really good practice to declare your variables const. If they can be const, make them const. And that goes for your function arguments as well. Right? If you're not going to change it, after you've initialized it, make it const. So, pass by const reference is probably, would you agree, probably, the most common way to pass arguments around in C++. So it's sort of the default way of doing it. Unless you're doing something whereby you need to change the value, you'll pass by const reference because it avoids the overhead of copying. Now sometimes you want to take a copy if you're going to operate on the thing, but usually pass by const reference is the thing you want to do. Am I posing for this time?
No, just because the screen froze paste.
Oh. So let's just have a quick example of that. I've got this function print int, and it takes as its parameter a variable named I of type reference to const int. And it prints the int. I couldn't be bothered to type it again, so this time you get life, etc. And now we call print int life, etc. Now here's the point. If you just saw this line, if you saw this line print int on your, and you pass it life, etc. If you just saw that in somebody else's code, and all you knew about the function print int, well, print int probably gives you a good clue about what it does, but let's say it's called, Frobnify. You saw Frobnify, because whoever wrote the program is as bad at naming things as I am, right? If you see that parameter type is constant ref, when you get down here, you don't have to worry that print int is going to have messed about with your nice int variable here. Shut up. So really, you thought I was going to add something. In fact, I thought I was going to add something, but there's nothing to add. Passing by const reference is nice and simple. Gets a reference to the original thing, but it can't change it. It's the best of both worlds. It should be the default way of passing things, unless you're doing something special. So I did have another exercise at this point to practice with const references. We are very pushed for time. So either I can set you going on this exercise, which will probably be it, or we can skip that. You can do it in your own time, and I can go on to do a bit more chatting. So it's entirely up to you which you want me to do. Chatting. All right.
We're going to miss you for 2 weeks. We need to.
Oh, you'll have Ollie. You won't want me back after that.
Well, maybe you will.
Yeah. Right, so we've got 19 minutes left, and I'm on slide 22 of 39. So it's going to be rapid fire talk about pointers now. Sorry, had you finished with that? Yeah? All good? As I say, the slides will be online just after Lauren reminds me.
If you paste me that code, I can put it on Classroom. Like, paste me that slide.
Oh.
Text from it, I'll put it on Classroom.
I will do afterwards. Pointers. Sorry.
Just a quick thing, everyone. So for doing this homework assignment, if you want to do it, if you've got a GitHub account, we have GitHub Classroom. So we can send you, those of you who've got it, come to me, we'll send you a link, and then you can actually do the assignment nicely just by doing it all from GitHub, and it's all tracked.
I think it's probably worth getting everybody set up with that.
How many people have GitHub account?
Everybody.
Pretty much everyone.
It's a very easy job.
Cool. Right, if I mess with your Mac to fix the slide.
Pointers. Who's heard of pointers? Heard of them. What have you heard about pointers?
Pointing.
They're scary.
They're scary, they're horrible. So C is all about pointers, C++ is all about pointers. It's all about managing your memory and really hard and leaking things all over the place and all these horrible O, X, blah, 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 blah numbers. And some letters as well. Hexadecimal. That's what he said.
Do you go into play? Is it play?
Play. C++, modern C++. We don't use pointers all that much. We don't use them anywhere near as much as people think they do. We have these things called smart pointers. And smart pointers we do use quite a lot, but smart pointers are a lot better. Smart pointers are smarter than dumb pointers. We're not going to be talking about smart pointers today, though, because we need to learn a bit more before we can really use them. So we're going to be talking about what are called raw pointers. These are the kind of pointers that are built into the language, the dumb ones. You can get yourself into trouble using pointers, but if you keep in your mind what they are and what they represent, then they're not really all that hard to get your head around. It's a bit strange to start with, but once it clicks in your brain exactly what a pointer is, you won't worry about it too much. So a pointer is a value that represents the memory address of some other variable. It's a variable that holds the memory address of another variable. How does this fit into Word documents? Anybody think what this might... Perfect. Very good. Yes, absolutely. So it's as if you have a document, and in this document it contains the file name of some other document on your computer. So in our analogy, the memory in your computer is represented by files on the file system. So we had two windows looking at the same file. When we were talking about references, there were two windows looking at the same file because they're looking two references to the same bit of memory, right? So a pointer is a value. It's a file of its own. Excuse me. It's a file. I get very excited talking about pointers. It's a file of its own, but it contains the address, the file name, or the memory address of some other file, some other variable. So I just said we're talking about raw pointers as opposed to smart pointers. We use them much less frequently in C++ than in C. C doesn't have references, so you have to use pointers everywhere. A good rule of thumb, use references when you can, pointers when you have to. We're going to see, well, we probably won't actually because we're going to run out of time. We talked about dangling references earlier. It's easier to get yourself in a dangling pointer mess than it is to get yourself in a dangling reference mess. And syntactically, I mean, in terms of the things you have to type, references are just easier to deal with than pointers.
Can you make me an example of when you have to, in my short experience, I never encountered some instance in which, oh, here I really need a raw pointers instead of a reference.
Yes, so there are, did this, last time I think I was in this room even, might have been that room. And we came up with 4 examples between us of when you would use raw pointers. So one is as an iterator type for a raw array. An iterator of the basic array that is built into the language. Yes.
But that is already a basic.
It's on the heap.
Already a pointer.
Sort of. It's not, but it decays into a pointer. But we don't.
Okay, but
We haven't got time to get sidetracked into that now.
Okay.
So they turn up as iterator types for raw arrays. Well, you don't want to use raw arrays. You want to use the library types because they're better. So you won't really run into them there. When you're doing low-level work with like raw memory, you're writing operating system device drivers, or you're doing your embedded programming, you'll run into pointers because that's just how you interface with the hardware. You can use them as a sort of reseatable reference. So I said once you've created a reference, you can't make it point to something else. Well, as you'll see in a moment, you can make pointers point to something else. So if you need a reseatable reference, you use a pointer for that. And the fourth is as a kind of optional reference. So again, we're not today anyway, not going to get into, there's a type in the standard library called standard optional, so you could have an optional int. Many languages have this kind of optional type. Most functional languages, Haskell's got one, Swift's got one, Rust's got one, Go's got one, I think. C++ has one, but you can't have an optional reference, you use a pointer instead. So for...
The only complete one seems to be second to me when you go and write to a low level in some device.
The fourth one also comes up.
Does malloc always give you a pointer?
Malloc does return a pointer, yes, and also the C++ equivalent, which is called new, returns your pointer. However, you don't want to use new, and you certainly don't want to use malloc, never use malloc, and don't use new these days either, because smart pointers that we'll get on to talk about offer much better, safer alternatives to these low-level memory operations. So we said a pointer holds the memory address, file name, of some other variable. So how do we get the memory address of a variable? We write the same symbol, an and, but instead of on the type, we put it in front of the variable name. Yeah, there aren't that many punctuation marks, so we've got to reuse them. So here I'm creating a new variable called address, of deduced type, and I've initialized it with and I. This means the address of I.
Is there an address type somehow?
An address type?
Yeah, because you've used auto there.
Yeah, what do you
Yes, the variable address has type pointer to int.
Yep.
So I've used auto specifically because otherwise we get into a sort of mess of how do I show you how to initialize the type of something anyway. So I just use auto as a kind of placeholder to avoid recursion. So we write a pointer type by putting an asterisk. So we write a reference type by writing int and. We write a pointer type by saying int star.
What happens if you don't write the asterisk?
Sorry?
What happens if you don't write the asterisk?
If you don't,
Yeah.
then you would just say int I equals something. So you'd be declaring a new int.
A new int.
Yeah. So like this line here. So there's no asterisk or and there. So this is just declaring a new variable of type int. So we can rewrite this. Sorry, it's very low on the screen again. We can rewrite this. These two things mean exactly the same. Instead of auto here, I've written the type out longhand. It's the same number of characters in this case. Int star. So address is a value of type pointer to int. We read them right to left. Pointer to int. And we've initialized it with the address of I. Yes?
So you know you have auto address equals I.
Yeah.
If you have comma j equals I, would that work on the same thing?
What, up here?
Yeah.
Yes. No. Yes. Yes, it would, I think.
I don't know.
Yeah, because the two are going to deduce to the same type, so it'll be all right.
One is int pointer, the other one is string.
Oh, sorry, I thought you meant j equals, yes, you're right. You get a deduction failure. It would complain there.
Quick point as well, the many guidelines suggest that you use auto star there to restrict auto to being a pointer.
Yeah. So you could also here write auto star if you wanted to.
Same.
And they would be the same, yes. So
it's a restriction.
So yes. Auto star means I want a pointer, but I will deduce what kind of pointer that is. So, unlike references, pointers are value types. Why we had that revision about value types at the beginning? Well, one of the reasons. Pointers are value types. It's like if it's a Word file that contains a file name of something else, right? This means we can copy them, we can modify them. Just like we can with an int, or with a string, or with a double, or any other value type. In particular, pointers are themselves variables. Which means we can take the address of a variable. We can take the address of a pointer. So this is a document that contains the file name of a document that contains a file name which contains a thing.
A shortcut.
A shortcut on your file system, absolutely.
A shortcut to the document. And you make a shortcut to the shortcut.
How about reference? Can be a shortcut?
So it's a pointer to a pointer, which we write int star star. And you can just go on and do as many stars as you like.
For no likely reason.
Sorry?
Not very likely to have a reason to do so.
No. Yeah.
Is that how the native C++ array works? Because you can just have references to each element in the array and just have a reference to a reference to a reference.
Yeah. So the raw arrays, the C arrays, the horrible arrays, we only have one-dimensional arrays in C++. So you have a one-dimensional array of pointers, and each of those pointers is in fact another array.
Can't have a reference to a reference. There's no such thing as a reference to a reference to a reference.
So a reference is not a value type, it's a reference type. Reference. But a pointer is a value type. So a lot of people, when they're doing these introductory courses, they will say, oh, well, a pointer's just like a reference, but you can do a bit more with it. Which, on the one hand, they're right, because that's true. Everything that you can do with a reference, you can do with a pointer with a bit more work. But sort of on a fundamental kind of level way of thinking about it, pointers and references are really quite different things.
Maybe do a whiteboard, show you like.
I would, but I just haven't got time. I've got 4 minutes. And I want to come to some sort of natural finishing point. So in particular, unlike references, we can change what a pointer points to. Pointer value type, we can change it. It's a file on the computer. We can change that line, change the file name that it contains. So here I've declared two variables, I and j. Initialized p. P is pointer to int, and we've initialized it with the address of I. And now I've modified p. I've said p equals the address of j. And this is perfectly fine. So p is a value type, we can modify it. If we try this with references, you're going to get assignment through the reference. It doesn't work for references. The pointer is something quite different. Yeah?
Could we use the reference, the pointer without reference?
Pointer without a reference.
The
Here?
Yeah.
Okay, so this means take the address of I. So if you don't have that, what you're trying to do is to say, I want a pointer to an int, but I'm going to initialize it with the value of the int, which doesn't really make any sense because they're different types.
Would that be a compiler?
It would be a compiler.
What does the actual address look like?
It's just a number. It's just a number. They're typically written for, I don't know why, they're written as hexadecimal. So they're written as like 0x and then some hexadecimal
John,
digits.
you can see out, if you do a pointer like that, and then see out on it, you'll see what the address is.
Yeah, but that's just a number. You could write it in decimal.
Yeah.
So, yeah.
Why did you say, if you assign it just to I, why is that a compiler?
So if I didn't have the ampersand here, because they're different types. So the thing on the right... Sorry?
You can assign it to 0.
Only a literal 0, I think, converts to a pointer.
Yeah. Only literal 0 or null pointer.
A literal 0. So, yes. We're not going to talk about null pointers. We would talk about null pointers if we had time.
So this is not a literal 0, or this is a...
No, literal 0 is literally the
Literally,
0.
so this character here is this literal 0. I is an int whose value happens to be 0. So we can dereference a pointer to take a look at the thing it refers to. So our analogy, we've got the file name. Let's say there's a magic function, you right-click on it, and it opens a window that gives you a view of that. So I couldn't be bothered to do a temporary, an int in there. So just say we have a pointer that we've initialized to something, and then we say star p is equal to 4. This means take the thing that p is pointing to, which is going to be an int, and set that equal to 4.
Automatic conversion work the same with pointers as well as 0?
Automatic conversion.
For example, if it was a char and they assign a 4 to the pointer to char, does it get converted?
So this thing, when you do star p, that's going to give you a reference to an int.
Yeah, if I declare p as a reference to a char, and then I put asterisk p equals to 4, does it do the conversion for me or not?
You can't.
So if you declare p as a reference to a char, or as a pointer to a char, yeah. Which one do you mean?
As a pointer,
as a pointer to a char, and you set that equal to 4, that would be okay.
Okay.
Because 4 can fit into the size of a char, which is 127 or 255. Oh.
Can you put the code without any semicolon after that and without any initialize?
So can I omit this semicolon here? Up here?
Yes.
No, there should be a semicolon there.
And the equal should be there, or can you put the equal without any number?
Can I just put a semicolon there?
Yeah, basically you put equal, but you didn't initialize it to any number.
That's exposition.
So can you do that?
Can you have an uninitialized pointer? You can.
Yes.
You can. It's a very bad idea. It is a perfectly legal thing to do. It's a very bad idea to do. So
don't do that.
So that's the perfect...
that's why I've said equal something, like just initialize it. Initialize it to some actual int. Maybe. So when we call star p, so why we would introduce references first, star p gives us a reference to an int. Which allows us, as we've seen, to modify the pointer to object. And as there was another exercise coming up, I was really ambitious today, wasn't I? I thought you were going to race through things. This is probably a good time to finish because it is now 2 minutes past 9 and we're going to get chucked out in a minute. So I'll pop that up on the screen for the people who want to basically taking your swap but doing it with pointers instead of references.
And for those who wants to do manual memory management, you have to look like this if you want to apply that.
Yeah, you've got to grow a full-on neck beard. Sorry? Yeah. I was in a room with about 20 of them, and I think I was one of 3 men without beards.
Are you going to apply the slide on GitHub?
On GitHub, yes, I will.
So I can refer to set aside.
Yeah.
Yes.
Yeah. So we're not going to talk about null pointers, or at least not this week. We might do it next week. Ollie might do it next week, because...
Yeah, it might be an idea. Does everyone fancy that? Next week we'll just pick up with this? Mm-hmm. Yeah? Alright, cool.
If you want to, if those 2 exercises I've left you with weren't enough, I did suggest some exercises from the book. We've been flicking about a bit. So Straustrup introduces pointers a lot later. When we were coming up with the syllabus for this course, we put it earlier. We're actually introducing it a lot earlier than we did last time around. But.
So all the pointers, all the stuff that we need to, if we want to review pointers.
Yeah, I think, to be honest, you cannot really cover pointers in 15 minutes, like I've just tried to do.
I'm a bit...
So if that's all left you in a bit of a daze, don't worry. Ollie will tell you all about it again next week. Right, because you cannot do this subject justice in 15 minutes. We'll probably spend a whole 2-hour session about it, to be honest.
We felt we'd start you with this stuff early because it's the best way to get you writing programs that crash as soon as possible.
So anyway, thank you for coming, everybody. Anybody's coming to the pub, come to the pub.
Yes.
Oh.
I don't know, I think I might have found another application.
Another application of